Alright, good morning everybody from the Four Sigmas. Today we're doing ideal gas law apparatus, and so what we've done is we've already set up our experiment. The ideal gas law apparatus is at 40, and what we're going to do is we're going to compress the plunger all the way down, hold it for 30 seconds until the temperature stabilizes, and then let it go back up to or near its original pressure. So I'm going to start recording data, and Chris, fellow Sigma, is going to compress the plunger. And we're ready to go. So Chris, 3, 2, 1, and go. So we're going to wait about 30 seconds until the temperature fully stabilizes. And it looks like it's pretty well stabilized there. So Chris, I'm going to ask you to release it. And now you see our pressure is going back near to what we had originally. Now it probably won't go all the way back up because of friction in the tube, but we're going to get near to where we were before. And it'll get almost to 1 atmosphere, not quite there, unless we let it go for a long time, and even then we might not get exactly, but it'll be close. And now you see we're about at that temperature that we were at the top here, which is good because we want a constant room temperature for both sides. So I'm going to stop the recording here on the data, and now we have a pretty nice graph of what we're supposed to be looking at. Now, this is temperature in Kelvin versus absolute pressure in kilopascals. What we're going to want to do is actually split this up into 2 graphs. So we're going to make a new page up in the corner here. And we're going to drag 2 more graphs onto this page. And just a note, we are using the PASCO Capstone program with the 850 universal interface. Now we're going to select our measurements here. We want time on the bottom and temperature. And we're going to switch our temperature units to Kelvin. And on this one, we are going to use time again and absolute pressure in kilopascals. And now these graphs are actually looking pretty decent. Ideally, we would have a little bit more data from before the compression, but it's all right for our needs. This is pretty linear going up, which shows a good quick compression without much stuttering. And it goes back down to a fairly stabilized level. So this is how you get those 2 graphs from our original data. And if you want to measure what it's at a specific point without looking at the data table, because we have, what is this? This is almost 1,500 data points. We can go up here and get our coordinates tool and drag it over to a point right here. And see, this will tell you the temperature in Kelvin and the pressure in kilopascals. I think that's all for today. Thanks for listening.
Good.